Okay, so we're going to have a look at a question from Advanced Mechanics. So this question is, what is the difference between orbital velocity and escape velocity? So we're going to think about this with a little diagram. Imagine we have a planet or some mass here. It has an object orbiting it like this. And the object is in a stable orbit path. Doesn't need to be a circle, but let's imagine it's a circle. Orbital velocity is the velocity required in order to retain this orbit. So orbital velocity is the velocity required to retain fixed orbit. So if this object wants to continue to go around this planet in this same orbital path, it will need a particular orbital velocity. And depending on the orbit will depend on that velocity. So if you have a very far out orbit like so, this will have a different orbital velocity. And you'll have seen formulas for these already. Now, escape velocity is a slightly different concept. Escape velocity, this is the velocity required to leave orbit. So if you have a particular velocity and you'll orbit the planet in a particular orbital path, if you increase that velocity, the orbital path will change. If you increase that velocity enough, the object will simply leave the gravitational field of the mass. So this object in yellow traverses this circle because it has a particular orbital velocity. But if we pick a different color, we might pick purple, if the object for some reason had its speed or its velocity massively increased to the escape velocity, it would no longer follow this orbital path. So the escape velocity might be a vector something like this. It would just leave. It will just travel off. It may continue to curve, but it'll just travel off forever. So it will leave the gravitational field of the mass, and it will essentially leave its orbit, and it will not take up any other orbit. So this is the difference between orbital velocity and escape velocity. One is required to retain a fixed orbit. The other one is required to leave all possible orbits.